All right, Math 3, Section A, and this goes along with Worksheet 1. So today we are talking about end behavior. Okay, so in a parabola, okay, so you have your parabola with your U-shaped graph, correct? So when you're talking about the end behavior, we are talking about each end of the graph, okay? So this end of the graph goes to positive infinity, and this end of the graph also goes to positive infinity, okay? Now, in order to tell some of these things, we need to understand what each part of the equation means. The first thing we have is the degree of a polynomial, okay? The degree of a polynomial, and they're basically saying you could have this big old long list for the equation, okay? But ultimately, it is just the highest exponent in the polynomial gives you the degree, okay? So if we look at those examples for f of x, g of x, and h of x, starting with f of x, what is the highest exponent? 5. That is my degree. So my degree is 5. Okay? G of x. Good. And I like that you notice that your highest exponent, it doesn't always have to be written in the correct order. It should be written in descending order with highest exponent to lowest exponent, but sometimes it isn't. And so you'll notice that 3 is right here, there, so the degree is 3. And then what would be the degree for the last one? 1. Good. Okay. The next thing that's important for graphing is the leading coefficient. And your leading coefficient is always the coefficient of the highest degree. Now, what does coefficient mean? Very good. Coefficient is the number in front. That's including positives and negatives. So going to f of x, what would be the leading coefficient? 3 is correct. Okay, so the leading coefficient is 3. Good. And then on g of x, what is my leading coefficient? 2. So what's the highest exponent? 3. And so that leading coefficient is negative 5. So it's always the number in front of your highest exponent. And then the last one, the leading coefficient would be 2. Good. Okay. The end behavior of the graph of a polynomial f of x describes the value of f of x at the far right and also the far left ends of the graphs. There are 4 possibilities of end behaviors for polynomials with the degree greater than 0. So obviously, if you don't have a degree greater than 0, it's just like x equals 5. There's no, I'm sorry, my voice is weird. There is no variable with an exponent. Okay, so here you can see that on the left side it goes to negative infinity, and on the right side it goes to positive infinity. Here both of them go to negative. Here one goes to positive and the right goes to negative, and here both of them go to positive infinity. So in math this year, a lot of you will be taking the SBAC test, okay? And that's the one on the computer. And one of the things that they're going to ask you to do is justify your answers. And when you're justifying your answers, you have to write a sentence that explains what is happening. And so there's quite a few pieces in this unit, and specifically today, where we're going to write a sentence explaining what we know, okay? And so please write it out because it'll help you with your homework. And when you write things out, it'll become where you know it. You remember it because you keep writing it. Correct? Okay. So this says describe the end behavior of the following graphs. First of all, what do we notice about both of these end behaviors? Okay, good. They are both going to positive infinity. And right here, I'm going to go ahead and write right and left, and we're going to do just the positive infinity. Okay? And now we're going to write it in a sentence. Since they are both going the same direction, I can write the right and left together. And so what I mean by that is we would put on the left and right f of x goes to infinity. So that's all you have to do for that sentence. Okay, over here. What is happening on the right and what is happening on the left? Good. Right is negative infinity, and then on the left side it's infinity. So this one I kind of have to write it as two separate pieces of information. So I'm going to write on the left, f of x goes to infinity, and on the right, f of x goes to negative infinity. This next part, we're going to look at a bunch of graphs. Does everybody have this? Not quite yet. And we're going to kind of try to see if we can figure out patterns and knowing how a graph should look without actually graphing it. Yeah, we might have to just go back in a minute. Okay. All right. Okay, so onto this side. So on each of these, when we're doing our end behavior, your right end behavior is actually a little bit more important than your left end behavior. So I always want us to start by looking at the right end behavior first. But on each of these end behaviors, we're going to have a right and left. Okay? What would be the degree on this polynomial? Very good. 3 is correct. My leading coefficient is what? 1. Because remember, if there isn't a number, there's actually a number 1 in front. And since 3 was my highest degree, my leading coefficient goes with that highest degree. Okay, my right end behavior is going where? Good, positive infinity, and the left is going to negative infinity. Okay, so we're going to go through and do this on all of these different graphs, and the reason is we're going to end up hopefully being able to figure out some information. Yes?
On this last one you just did, you wrote out the sentences on all of them?
On these, we're not going to write sentences. When we get to another part of the notes, we are. Okay, but for these, we're just going to do right and left. Okay? All right, so what is the degree on this one, the next one? 3, leading coefficient is negative 2. My right end behavior is good, and my left is perfect. Okay, the next degree is 2, leading coefficient, negative 1, and my right and left both go to perfect. Okay, next row. What is my degree? Leading coefficient? Negative 1. And then my right and left both go to perfect. Next one, my degree is 5. Leading coefficient is 1. And then we have our right and left. Right is going to good, and left is perfect. Okay, next one, the degree is good. Leading coefficient 1. Right and left are both going to positive infinity. Am I going too fast? Yes. Are we going? How am I getting the degrees? Great question. So the degrees is always your highest exponent. So it's not always in like the exact order of it being the first term, but yeah, your degree always comes from your highest exponent. Okay. And then once you have the highest exponent, it's the number in front that's your leading coefficient. Any other questions so far on this? Okay, so the third row, are we there? Okay, what is my degree on that one? Good. What is the leading coefficient? 0.2. Good. And the right and left are both going to, good, positive infinity. You'll notice sometimes that they might put a plus in front of the infinity to say positive infinity. It means the same thing as just writing the regular infinity. All right, next one over. What is that one? 5. Good. 5 is correct. And what's my leading coefficient? -1. My right in behavior is good, and the left is good. Next one, the degree is 2, leading coefficient. The right and left are both negative infinity. Okay, last row. What is my degree on that? Good. Leading coefficient and behavior. Right is going to the good, and left is positive infinity. The next one, the degree is 3, leading coefficient. 1, right in behavior, and left, good. Okay, last one here. Good. 1. Perfect. Okay, so either by yourself or with someone that you're sitting by, I want you to see if you notice any patterns. Like based on the degrees and coefficients, are there any patterns? Okay, does anybody notice anything? So let's look. It says the left and right end behavior of all even degrees. So go back and look at all even degrees, and what do you notice about their end behaviors for every even degree? That's it. They all go into the same direction. So what happens on all of the odd degrees? So go back and look at all the odd numbers. Very good. They do. They go in opposite directions. Now, I remember the odd one is the easiest for me to remember because odd starts with O and opposite starts with O. So anytime it's an odd degree, I know it's going to be opposite. And then I know that evens, because odd is opposite, evens are the ones that go in the same direction. Okay, so odd, opposite. What?
Evens level out evenly, go the same direction.
Good. Okay, so the right and behavior. So I told you we're going to look at the right and behavior more often. The right end behavior has a positive leading coefficient. What do you notice? So you're going to look at the leading coefficient and the right end behavior. What do you notice? What do you notice, Josh? Oh my gosh. Oh my goodness. There we go. Perfect. Okay. No candy for that one, though. That just happens. Okay. All right. Back to this, though. Right end behavior. And a positive leading coefficient. What happens? It goes to positive infinity or it goes up. You can either think of it either way. Your right end behavior, if it has a negative leading coefficient, what happens? It goes down, or negative infinity would be more appropriate. Okay. Questions before I move on to this next page? We're good so far? Okay. So we have this little chart here. So we know that even degrees go in which directions? Same directions. So if it's positive, what's going to happen if it's an even degree? Your right goes up and your left will also go up. Now, if you have an even degree and you have a negative coefficient, that means that your left will go down, which means that your right goes down, which means that your left also has to go down, because evens go in the same direction. Okay? So, if you have an even degree and a negative leading coefficient, everything's going down. If your leading coefficient is positive, everything's going up. Okay. Now, for your odd degree, odd, we know that they go in the opposite. Let's see if I can spell it right this time. Okay. So, if I have a positive coefficient, that means the right side is going up. Therefore, the left has to go down. Say that again? Okay. If we have an odd degree and has a negative coefficient, the negative coefficient tells me that it will go down on the right, but since it's odd, it's going to end up going which way on the left? Up on the left. And then what happens in between? Today, we can just make anything we want to end up connecting the two arrows. Okay? So like these could end up making parabolas, or you could kind of do a squiggly line in between. These could actually come together and make a line going in opposite directions, or you could do different things in between. Okay. So this next part, and we're going to have to do some writing on this, okay? It says identify the end behavior of this equation. So first thing you need to notice is the degree. So what is the degree of this polynomial? 3. Okay, so my degree is 3, which means, what kind of number is that? Odd. And odd means they will go in opposite directions. Okay, and then we have our leading coefficient, and our leading coefficient, all we basically need to know is it positive or negative? It's positive. So since it is positive, I know that the right side will go which way? Up or positive infinity, okay? So we're going to write this out now. So here is our sentence, okay? On the right, f of x goes to infinity, and on the left, f of x goes to where? Negative infinity, since, and this is how we tell them how we know. Okay, so we know that on the right, f of x goes to positive infinity, and on the left, f of x goes to negative infinity, since the leading coefficient is positive, and I'm going to abbreviate there, and the degree is odd. Okay, so again, we're just basically saying what's happening with each of the end behaviors, and then we're stating how we know it. So we know it because of the degree and the leading coefficient. Okay, so what do you think is going to happen with number 2? So we first look at the degree. And is the degree odd or even? You're right, it is 6. Thank you. Okay, so the degree is 6, and is that odd or even? Even. Which means it will be going in the same direction. And then we have to look at that coefficient. Okay, so my leading coefficient is what? Negative, which means that the right will go down or negative infinity. So we need to write another sentence. Now, since they're going in the same direction, I can put on the left and right at the same time. So it just makes my sentence a little shorter. Okay, so on the right and left, f of x goes to negative infinity since, and then what would we write at this after the since part? Yep, leading coefficient is negative and the degree is even. Good. So since the leading coefficient is negative and the degree is even. Okay, any questions or clarifications? Yes. I put RT for right. So meaning the right side, the right end behavior goes down. Yeah, so it's the right end behavior. Any other questions or clarifications? Okay. Number 3. So it says identify whether the function graph has an odd or even degree and a positive or negative leading coefficient. Okay, so odd or even degree and positive or negative leading coefficient. And it says justify. So again, that means I'm going to write a sentence. Okay? But before I do my justification, I kind of like to figure out what it is that's going on. So is this one going to be odd or even, and how do you know on number 3? Odd. And we know it's odd because they are going in opposite directions. Okay, so again, I remember odd because odd and opposite both start with O's. Okay, now will it be a positive or a negative leading coefficient? So I'm just going to put LC for leading coefficient. And it's going to be negative. Good. And we know that how? Good. You always look for your leading coefficient. You're always looking at your right end behavior. Okay, and again, you don't have to write all this out when you're doing your homework, but I like you to write it in your notes so that when you go back and look at it, you know exactly what we are talking about. And so again, this right end behavior, it's going down, and that's why it's gonna, my leading coefficient would be negative. Okay? We don't know the specific degree. We only need to state whether it's gonna be odd or even. And so we know it's odd because it's going in opposite directions. Okay? Anything else? Okay, so now we have to write our sentence. Our sentence is basically almost going to be the opposite of what it was up here. Because this one, they gave us an equation and were asking us how would the graph look. And now we have what the graph looks like, and they want us to basically say what the equation would be or look like. Okay? So, we're going to state the information. So we're going to put the leading coefficient is negative, and I'm going to abbreviate negative, and the degree is odd, since on the right it goes to negative infinity, and on the left it goes to infinity. And that's it. Okay, number 4. So again, we have to decide, is it odd or even degree? And my leading coefficient, would it be positive or negative? So is it going to be odd or even? Even. And how do we know that it's even? Same direction. Okay, leading coefficient, is it going to be positive or negative? Positive. And how do we know that it's positive? Your right end behavior is going up. Okay? If the right end behavior is going down, then it would be a negative coefficient, right? So the right end behavior lets us know if it's a positive or negative in your leading coefficient. Do you think you guys can write this sentence? Or some of you already writing it? Okay, so we're just going to do it the same way. So you can look at what we've written over here. So this one says the leading coefficient is what this time though? Is positive. And the degree is even, since on the, and this time we can put right and left, right? Since on the right and left it goes to infinity. You guys get it. You know what it means. Whatever. Okay. All right, number 5. Are we good here? Besides spelling, we're okay? You guys know how to spell better than me. That's good. No? Okay. All right, example 5. So here they just want us to write an equation. So we don't have to do any justification, which is really nice. And there are a lot of different equations that could be written. So it says f of x with an end behavior on the left, f of x goes to negative infinity. So we have the left, it goes to negative infinity. And on the right, it goes to negative infinity. So what does that tell us about our degree? So since these are the same, it's going to be an even degree. Because remember, odd is opposite, O, right? So since these are not opposites, they're the same, it has to be even. Okay? Now, the right end behavior is going to where? Negative infinity. So therefore, my leading coefficient has to be negative. All right, so they're telling us to write this as f of x. So I'm going to put f of x equals. So I need a negative leading coefficient. You can use any number you want. Anybody have a? Okay, negative 3. And then x, it has to be to an even degree, to the fourth. That's really all you have to write. You could end up putting like minus 7x to the third plus 2x minus 5. I don't know. You could add anything you want to. The only thing, though, that's important is your highest degree and your leading coefficient. If you wanted to write more on at the end, you can. If you don't want to, you don't have to. Okay? But it could be there or not be there. Does that make sense? Okay. So this would be a possible answer, although you could have written something different. It just has to have a negative coefficient and an even degree. So could I put 20 as my degree? Yes. Okay, number 6. Okay, you need to read through that one, and I'm going to walk around if you have an example equation to check it to see if it's correct. You could even check with someone you're sitting around and see if you guys agree. They don't have to be the same answers. Anybody have one yet? Okay, good. Most of you that I've checked out have it correct. Good. And so, first thing is that they are going in opposite directions. So since it's opposite, that means it will be an odd degree. My leading coefficient is only looking at the right. And so the right end behavior goes to positive infinity, so my leading coefficient will be positive. This one they told us to label it g of x, so g of x equals, and I'm just going to write 2x to the 7th. Okay? Any equation would work. This number just has to be positive, and your exponent has to be odd. Okay. Any questions? All right, moving on. Okay, so sketch a graph of a polynomial function with a positive lead coefficient and an even degree. Okay, so the even degree tells me that are they going to go in opposite directions or the same direction? Okay, so I'm going to write over here, same direction. And then a positive lead coefficient means that the right end behavior will go which way? Up. Okay? So if we go over here to the graph, I'm going to have same direction and both of them are going to go up. So we have an arrow going up here and up here. And in the middle, you can do whatever you want it to do. Okay? So you can make a couple curves. You could have made it a parabola. You could have done whatever you want it to do. Okay? But basically, in the middle, it doesn't matter how you connect it right now. It will later, but right now it doesn't. Okay? All right, you try to do number 8 now. Okay, so since it's an odd degree, they're going to go in opposite directions. Okay? And then a negative coefficient means that the right end behavior is going which way? Very good. Down or negative infinity. So that means over here will go down, and over here it will go up. And again, it doesn't matter how you connect them. You could have made it a line, okay? And I'm just going to connect it like that. Okay, but it doesn't matter as long as they are connected. Questions on anything from today? No?